So we're going to talk about one mean z-test. So what we're doing in this is we're comparing a sample mean to a population mean. And if we know the population standard deviation, we can use a one mean z-test. So go back to Unit 2 when you learned about normal distribution and you learned about z-scores. So now we're going to focus on a z-test and we use the normal distribution. So what we need is a population mean, and that's the mean that we're going to use in those hypotheses. The sample mean x bar is the mean of the sample that we're looking at. The sample size is n and it has to be greater than or equal to 30 to use this test. The problem or the data set will show you how many are in the sample. The population standard deviation, sigma, has to be given to use a z-test. If not, there's another type of test we have to run. The level of significance, alpha, are the level of confidence. So this is basically what we're trying to do. As you can see on the left, we have a sample mean and a sample size. I'm trying to compare it to the population mean and the population standard deviation. If you can see here, I didn't put the sample standard deviation in my graphic of the sample because I'm not required to report that. It's great if you have it, but we're not going to use it in the z-test because we have the population standard deviation. So why are we running this test? We want to see if this small sample over here is different from our population. Why do we want to see the differences? Because maybe we're doing drug trials and we want to see if that sample lowered cholesterol or if it's a new type of technique for learning. So our whole goal of this is to see if that sample is different from that population.